graph the function and then state its domain and range. Part A, f of x is equal to square root of x. Part A here, I have square root function. So let's go ahead and graph it. We need to plot points. So we need to choose points for x. If you notice, x is in the radical. So x cannot be negative. Okay? So the least value that x can have is 0. So 0 is the smallest value for x that we can have. If x is 0, f of x would be also 0, wouldn't it? Because square root of 0 is 0, 0 times 2 is 1. Now let's select other values of x here. You can choose any values of x that are greater than 0, but it would be a good idea if you can choose values of x that would come out of the radical. So for instance, 1, 4, 9. So let's go ahead and do that. If we choose 1, then you have square root of 1. Square root of 1 is 1. 1 times 2 is 2. Right. And if we choose 4 for x, so we get 2 square root of 4, and we know that square root of 4 is 2. So we're going to have, we'll have f of 4 would be 2 square root of 4, which is 2 times square root of 4 is 2. 2 times 2 is 4. We can choose one more value, that is 9, although it's a little bit large, but it's fine. I made space for it here. If we choose 9 for x, we're going to get what? We're going to get f of 9 equal square root of 2 square root of 9, forget the 2. 2 square root of 9, which is 2 times square root of 9 is 3. So 3 times 2 is 6. Okay. So let's go ahead and graph the function. Okay, I have 0, 0. So here is 0, 0. That's the origin. By the way, this is the x-axis. This is f of x. Now, when x is 0, y is 0. When x is 1, y is 1, or f of x is 2. So x is 1, f of x is 2. Here's my second point. When x is 4, f of x is 4. Here's 4 right here. And here's the 4 right here. And when x is 9, f of x is 6. So x is 9. So, and then f of x is 6. So, connecting the dots, you're going to end up with a graph that looks like this. If you notice, it looks like an arc. Okay, and here is the graph of f of x equal to square root of x. Now they want us also to find the domain and the range. Now remember, the domain is the set of all values for which the function is defined. Now if you recall, we were just talking about this. F of x is not defined when x is negative. So x cannot be negative. Whatever is inside the radical cannot be negative. Okay, so you can also see it from the graph. X is not negative. So it's starting from 0 all the way to infinity. So the domain is going from 0, 0 is included, all the way to infinity. And it can go all the way like this. Continues. Now the range is the set of all values that f can take. Well, since x equals 0 is the smallest value you can have, the range would also be 0. You're not going to have any graph here, anything below 0 here. So the range the values of y it can have is from 0 all the way to infinity. So the set of values that f can take are from 0 to infinity, and you can also see it from the graph. So this is the graph of the first function. Again, let me write it down. This is f of x equal to square root of x. Now let's go ahead and graph the second function. F of x is equal -2 absolute value x. Again, this is absolute value function. So let's go ahead to graph. Let's go ahead and plot some points for x. Figure out what f of x is equal to for each values of x. So here x can be anything. You can choose negative values of x. So let's go ahead and do this. Okay, let's start with 0. Absolute value of 0 is 0. 0 times -2 is still 0. If we choose x is equal to 1, then absolute value of 1 is 1. 1 times -2 is -2. And if we choose 2, absolute value of 2 is 2. 2 times -2 is -4. Now let's choose values of x that are negative. So if we choose -1, we're going to have absolute value of -1, which is +1. 1 times -2 is -2. And let's choose one more when x is -2. So absolute value of -2 is +2. +2 times -2 is -4. Okay, let's plot these points. We're going to have the points are 0, 0. That's the origin right here. And when x is 1, f of x is -2. When x, this is by the way the x-axis. When x is 1, f of x is -2. Here's negative. When x is 2, f of x is -4. Here x is 2, f of x is -4. Now when x is -1, f of x is -2. X is -1 here, f of x is -2 right here. Now when x is -2, f of x is -4. So this is x is -2, f of x -4 is right. So the graph connecting the dots, we're going to have the graph that looks like this. Notice the largest value here, the largest value of the function is 0. Everything is below the x-axis as we expect, because even if you have positive or negative values of x, the absolute value is always going to make it positive. Positive times a negative number is a negative number. That's why all the values are below the x-axis except when x is 0. So this is the graph of f of x is equal to -2 absolute value of x. Now let's go ahead and write the domain and the range. Now the domain for my problem here, the domain is the set of all values for which the function is defined. Well, the function is defined for any values of x. So x can be anything. If you can see, you have arrows, so it can take on any values of x. So the domain for my problem here is from -infinity to infinity. That's the domain. However, the range is different. The range is the set of all values that f can take. Well, if you notice from the graph, the largest values that f can take is 0. Right? That's the largest value. So the range is anything that's negative. So from negative infinity, all the way from negative infinity to 0. 0 is the largest value that the function f can take. So the domain and the range.